Ever wondered how humanity reaches the stars? It all starts with a rocket. These magnificent structures towering above us are our vessels to the cosmos. They are the key to unlocking the mysteries of the universe, to understanding our place in the grand cosmic theater. Rockets are more than just vehicles. They are the embodiment of human curiosity, ambition, and our relentless pursuit of knowledge. They are the lifeline of space exploration, our future in the cosmos. But what goes into making these colossal machines? The first step to building a rocket is the design phase. Now, why is this vital? Well, it's like having a roadmap for a journey. You wouldn't want to start a trip without knowing your destination, would you? The same goes for rocket building. The design phase is where we consider key factors such as weight, aerodynamics, and the purpose of the mission. Weight plays a significant role in how much fuel we'll need, and aerodynamics dictate how smoothly our rocket will traverse the Earth's atmosphere. As for the mission's purpose, it determines what kind of equipment and technology we'll need to incorporate into our design. In this modern age, we're not just sketching out designs on paper. We're using sophisticated computer software to create intricate, precise blueprints. These digital tools allow for precise calculations, simulations, and adjustments, making the design process efficient and accurate. Once the design is complete, it's time to start building. So let's roll up our sleeves and bring these blueprints to life. The materials used in rocket construction are as vital as the design itself. We're talking about a vehicle that has to withstand the rigors of space travel, so the materials used should be both lightweight and strong. The most commonly used materials include titanium, aluminum, and stainless steel, each with their own unique properties. Titanium, for instance, is known for its strength and resistance to heat, making it a perfect choice for the rocket's frame. Aluminum, on the other hand, is lightweight and corrosion-resistant, ideal for the rocket's body. Stainless steel? It's used for the rocket engines due to its ability to withstand high temperatures. Once the materials are selected, it's time to construct the rocket. This is no simple task. It requires a great deal of precision and expertise. Each part of the rocket needs to be meticulously crafted and assembled to ensure the vehicle's structural integrity. Any small mistake can lead to catastrophic results, so accuracy is key. The rocket's frame, body, and engines are built separately before being assembled together. This process is lengthy and requires a detailed understanding of aerodynamics, physics, and engineering. With the rocket built, the next step is to power it up. The heart of a rocket is its propulsion system. Without it, our spacecraft would be nothing more than a well-designed tin can. The propulsion system's purpose is twofold: to overcome the force of gravity and to provide motion to the rocket. Now, how does this work? Well, it's all about Newton's third law of motion. For every action, there's an equal and opposite reaction. When a rocket expels fuel at high speed in one direction, it's propelled in the opposite direction. This is what we call thrust. There are two main types of rocket fuel: solid and liquid. Solid fuel is simpler and safer, but once ignited, it can't be stopped or controlled. Liquid fuel, on the other hand, can be regulated, allowing for more precision, but it's also more complex and potentially hazardous. Now let's talk about the launch. It's the moment of truth where years of hard work are put to the test. The rocket must overcome Earth's gravitational pull, a feat requiring immense power. The initial acceleration is slow, but as the rocket burns off its fuel, it becomes lighter and its speed increases. This journey is fraught with challenges, from the intense heat and pressure of the launch to the freezing cold of space. A rocket must be built to withstand extreme conditions. And with that, our rocket is ready to explore the cosmos. Building a rocket might seem like a daunting task, but it's all about careful planning and precise execution. From probing the cosmos, crafting meticulous blueprints, selecting the right materials, to mastering propulsion and launch, each step is crucial. This complexity is not a deterrent, but rather the beauty of this endeavor. It's a dance of science, engineering, and artistry, all converging to conquer the cosmos. Next time you gaze at the stars, remember the colossal effort that goes into reaching them. This is the art of rocket making.